Yeah, good morning. I'm happy being back at this conference. Last year I also joined, and today I want to speak how we're helping cities with data to make better decisions and tackle the problems we are facing in all cities all over the world. See, is it not forwarding? Here. So the challenges cities facing is very common. It's all about transformation of cities. Smart cities means it's about congestion fighting and how to overcome the challenges with a high load of traffic demand, emissions, noise, but also how to manage the efficiency of the operation. There's a common theme, and with data, we are providing tools to help cities to make better decisions and understanding the problems and transform. You can reduce the problem in general of congestion in a three-dimensional topic. Congestion is caused by high load of traffic demand on a road in a limited capacity. So you have to watch carefully between traffic demand, the capacity of your network, but also what's very important, the modal split. What the previous speaker was talking is one element of modal split, which is biking and ride-hailing is one element. How to manage modal split in a way that you reduce cars from the road and bring it in different mode of transport. Very common theme, how to fight congestion. And new tools to understand those problems and demand to make good decisions on transportation management. We have provided a full suite of tools to help, and I want to go through what we are doing. The fundament of our tools is data. Probe data we're receiving from different navigation devices in fleet, ride-hailing, in-dash navigation. And what is important to know, here in New York, in the US, 1 of 4 cars minimum, we have live data to analyze the congestion, the speed, traffic demand, which is the foundation for everything we are doing, and how we can help people understand the problem of congestion, but also implement change and measure the impact. This is an architecture view on our, what we call the fusion engine for live traffic. We get a massive amount of GPS data every second globally, in typically market in North America, Europe, Asia, Oceania. We have minimum 1 of 4 cars feeding in our system, and this is one big data source. But we also have data from the government. Where are constructions? Where are accidents? Where are road closures? We have community input from navigation applications, but also having operators for critical situations like disasters, helping to have a good picture of traffic, fuse the data twice a minute, and then output in navigation applications. And then we're getting back a lot of data in form of GPS. Again, the cycle starts again. When you're doing this is really a view how traffic looks like here in New York. This is a picture from a couple of days back. It was the longest jam at this moment in time. And you see even each triangle, how many probe data we are harvesting in our ecosystem. This is around about 33% of the car population in New York. We have real-time data. It's probably not so widely known because we are working with big tech companies, including Microsoft, ride-hailing company, in-dash, Toyota, you name it. And this is a massive pool of community, which is the foundation what we are doing. You see also in this picture, in red and yellow color, the large gem structures. The typical stop-and-go waves you can nicely visualize, but also see what pain some people are facing when they're driving on this interstate here in the New York City area on the I-95, a very hot spot of traffic, as you all probably know very well. We're also having gem information we're putting back to the device, gem tail, where is the traffic stopping is a safety feature, and this is important information for drivers, but also glowingly for autonomous cars driving in autopilot mode. What else we are doing? We're putting all the data in a tool set, what we call location analytics platform. And there are a number of products and tools where we can analyze the GPS data in real time, but also providing historical analysis to understand impact on construction, on a traffic jam, on accidents, how people move, what's the traffic demand, and this is a full suite being with data we are collecting for 15 years. So we can even look back what happened 10 years back in a certain road stretch, in congestion, traffic demand, route choice, anything what is interesting for simulation of today's future traffic and transportation demand. So here's one historical tool which is called Traffic Stats. So we're providing speed information, volume, route choice on a singular route of pre-choice in date, time, and also the route. But also you can analyze entire cities in terms of the same information with metrics, statistical metrics, even with percentiles in 5-step percentage resolution. Very good input also for simulation, for understanding impact on certain incidents like constructions, road closures, accidents, you name it. Origin destination is a very important tool for transportation planners. You translate the trip information from our probe fleet into demand pattern. This is very relevant for planning infrastructure, to understand the impact on construction of accidents, to make a good response in terms of guidance, but also how to control the infrastructure in form of traffic lights, signal timing, maybe have changed because there's different demand because of an incident. That's a tool to have. It's an historical product. Here in the screen you also see a demand analysis for Manhattan, how people moving in and out in a certain admin area in Manhattan area, but it can do it in a global basis in a different time scale, but also up to 50 minutes resolution. So very detailed insights what's going on traffic demand. Route monitoring is a tool where you can monitor routes in real time. For instance, I want to know what's the trip time to LaGuardia Airport or JFK. You can get real-time information on a 1-minute update, or from the probe data we're receiving every minute, and put it back in navigation applications in very, very different form. We are also moving towards a volume product. At the moment, I said we have around about 25% penetration, but we want to know what the total volume is, and that even without infrastructure like loops and detectors. What we're doing, we're using a fundamental law of congestion with the capacity, which is around about 200 cars per lane per hour. It's the maximum capacity. We can describe what the traffic volume is when you have a certain penetration, 20-25%. And this we used to build a complete new volume product, which has a number of advantages for many, many applications. It can measure impact, it can measure noise level, it can measure collective impact on CO2, carbon dioxide, or other economic measures to combine with speed information, route choice pattern, and to name the collective impact. So very important new product we are launching right now and is available already in North America. Here's an example for New York City. It's about annual average daily traffic pattern of volume, and we can go even down to hourly values to drive and stimulate certain application on collective impact. Very, very important extension of our portfolio in this regard. Here's an example for a bridge from Manhattan to the Jersey area. You see the different variation of traffic volume on a daily basis here for a couple of days in 1 week. And in the tool, you can do it for whatever time frame you want to do and whatever segment in the entire US that's possible. We also can go very microscopic. We have a tool where we can monitor junctions in real time with the number of delay, number of stops, queuing lengths, all the insights which is typically relevant for tuning and optimize signal timing control, but also quickly respond if there is an imbalance between traffic demand and supply of time to green for a certain direction. Very important tool, and we have many infrastructure companies like Econolite, Swarco, Unex, and others, using this product already to optimize time to green on top of the local infrastructure, which is very relevant, in particular for delay time and local OD pattern. The thing is, what we want to achieve is not only understand the problem, we want to go beyond, and we want to create impact. And what you can do with data, even without infrastructure, is putting the data back into play, into optimizing signal timing. Here's an example from Tokyo. We did with Sumitomo Electric for the city of Tokyo. They're equipping now 2,000 junctions in Tokyo with our solution, and we're feeding back continuously information to optimize time to green in real time, only with data, floating car data. There's no infrastructure required. We did a test even here, a comparison between infrared infrastructure and floating car. We came to the same results, completely infrastructure free, which is a huge benefit in terms of cost and also quality. And then the next thing is bringing this information back into navigation devices. So we also have an own navigation software, or our partners. We feed time to green back in the navigation stack and create impact even on a collective manner to the people, that people respond also to changes on intersection, but on all corridors, to respond to traffic and to different time to green. Impact via closing the loop. We're also measuring the congestion index, and this we're doing since 2011. Here's the result for 2024. The highest congestion city in North America was Mexico City, followed by New York. So this is based on floating car data. We are estimating the congestion level for cities on a typical 10-kilometer ride, and measure the travel time, and then make a ranking who it takes longest time for this typically ride. This we're doing for 500 cities. It's available on our website. You can have a look. It's free of available to look for your city where it stands in terms of congestion. This is more a marketing page and visibility, but now we're going a step beyond. This becomes a product. So in summer, we will launch a completely scalable API with the same method to build your own congestion index in space and in time. Back to a 1-hour resolution, you can build even your daily congestion index in your city, in your district or county. And this is the next step to enhance and enrich our portfolio, measuring impact. Even if you do something, what is the consequence on delay time? Can I measure improvement if I do better construction, better time to green optimization? I can measure the impact, A, with the delay API, with the traffic index, and B, with the throughput, with the traffic volume. Both interesting metrics to measure impact and learn from the past being better in the future. And then we can also go with the volume and the speed product into emission modeling, noise modeling. Here's an example for CO2. We're using a model from the University of Graz, and we also have already published this on our website during the index campaign. Another sustainability index, important for cities. We want to reduce CO2, we want to reduce noise. Here is a measure. You can see your impact. Coming also soon in the product. And then you can, a big thing for governments is road safety. Vision Zero is a big thing. ADAS vehicles coming, autopilot, very well known and growing. But it's all about safe speed. And we're also designing products to understand infrastructure and driver risk on driving pattern. Here we analyzed our floating car data for acceleration, deceleration, and speeding pattern, and we can provide hotspots of road safety risk in terms of infrastructure, but also on driver risk. And here is another product we're rolling out at the moment to complete our offering in a safety category to improving the index, give governments a hint also where are unsafe spots in infrastructure, but also where drivers have a high risk area, and there is something to be done to improve the road safety. Become also a global product, and we're starting with North America in a couple of months to roll this out. So far, a very quick roundup what we are doing as TomTom globally, also in North America, and I'm happy to answer a few questions. Thank you. Yes, they are available. You can contact me. You can also make a scan. You can test for free the APIs. It's free of charge.
You had mentioned a quarter or maybe 25% penetration, and you're making assumptions as to how that could represent the entire network or the volumes completely. Can you expand on that, especially when you're measuring queues and travel time?
We are the only company in the world have a very wide spectrum of probe data because we are feeding our traffic information into in-dash automotive, fleet management, taxis, ride-hailing, and navigation application on big tech. So we have a wide spectrum of different type of usage pattern in commercial sense, but also in private consumer mode. So it's the only company with this wide spectrum. In the US, up to 33% penetration on interstates. Very rich data set, very rich.
Since congestion pricing started, have you seen a reduction in traffic into Lower Manhattan?
Not. We haven't seen yet. So, but it's a very important point. I spoke a bit of creating impact. And impact, we want to create change, reducing congestion. And there are two ways to tackle this. One is penalizing the journey, that's road charging and parking fee expansion. But the other way is, in a positive mood, to transform the modal split in bikes, in transit, to make it in a positive notion, right? So both ways are possible. And again, I showed you two matrices which are leading. Delay time, API, is one matrix. Volume is the other matrix, it's throughput. We have everything at hand to measure the impact, what works in the city. And tolling so far didn't return yet the outcome, but at least we can measure it and can think and improve the loop in the loop, what can be done better to create an impact we wish for, right?
Time for one more? Anyone? Back.
Thank you so much. Just based on the competitive landscape, are there any startup ventures that your organization is looking to possibly acquire over the next coming years, just because of the advancement of AI in the next decade?
So we are continuously increasing our footprint. So one target is now hazard warning and safety, because we're feeding traffic and hazard information into ADAS system, including speed information to allow safe speed. It's a big investment, and we're using also machine learning models and AI to create agents, first to make the data more available in safe driving mode, but also for governments, we want to use co-pilot technology together with our partner Microsoft to really optimize decision-making on data for control center operation. You can imagine, if I know which are the worst performing junctions in the city, I can drive and change plan on time to green and measure the impact. So we want to really also use AI to have a co-pilot technology stack, an agent to improve data center operation.